What if you could run a 744 billion parameter AI model, one of the largest language models ever created, on a laptop with just 25 gigabytes of RAM? No cloud, no GPU cluster, no API keys. Just your machine, running a frontier-class intelligence locally in pure C with zero dependencies. This is Colibri, the tiny engine that runs an immense model. And today I'm going to show you exactly how it works, why it matters, and how to set it up yourself. Let's start with the problem. Right now, running frontier AI models requires insane hardware. GLM 5.2 has 744 billion parameters. Loading it traditionally would need over 1.5 terabytes of VRAM. That's an 8 GPU H100 cluster costing $30,000 per month. For most developers, researchers, and enthusiasts, that's completely out of reach. And even if you have the money, every prompt you send goes to a data center. Your data, your questions, your code, all of it processed on someone else's hardware. There's no privacy, no ownership, no way to inspect what the model is actually doing. Frontier AI has become a walled garden, locked behind APIs and cloud subscriptions. Colibri exists to break that wall down. Here's the breakthrough insight. GLM 5.2 is a mixture of experts model. It has 744 billion parameters total, but it only activates about 40 billion per token. That means 95% of the model sits completely idle for any given prediction. So why load all of it into memory? Colibri treats this sparsity as the entire design principle. The dense core, attention layers, shared experts, embeddings, that's about 17 billion parameters. At Infor quantization, that's just 9.9 gigabytes. That stays resident in RAM. The other 19, 456 rooted experts, about 370 gigabytes, live on your NVMe SSD and get streamed into memory on demand. Only when the router says they're needed. Think of it like a JIT compiler for neural network weights. A JIT compiler never compiles the whole program. It watches what actually runs and compiles the hot paths just in time. Colibri does the same thing with model parameters. Let's walk through what happens for every single token. Step 1, the router decides. Each token gets routed to 8 out of 256 experts per layer. But here's the clever part. The router runs one layer ahead. This look ahead is called pilot mode, and it lets the engine start prefetching the next layer's experts before they're actually needed. Step 2, a sync I/O kicks in. Missing experts get loaded from disk in the background, while resident experts are already computing. Each expert's 3 matrices are stored adjacently and read in a single peer-read call. No seeking, no fragmentation. Step 3, the LRU cache learns your workload. Every turn, the engine records which experts got rooted and updates a usage file on disk. Hot experts get pinned in RAM, cold ones get evicted. The more you use Colibri on a specific topic, the faster it gets, because the right experts are already cached. This is measurable structure, and structure is cacheable. The memory hierarchy is where the real magic happens. Colibri treats VRAM, RAM, and disk as one unified pool. At the top, VRAM. If you have GPUs, experts can be pinned directly in video memory for maximum speed. On 6 RTX 5090s with full expert residency, you hit 6.8 tokens per second. In the middle, RAM. The dense backbone lives here permanently at 9.9 gigabytes. Hot experts get pinned here by the LRU cache. A 128 gigabyte desktop with no GPU can hit 1.8 tokens per second just from RAM. At the floor, NVMe disk, the full 370 gigabyte expert store. On a 25 gigabyte laptop, everything streams from here. It's 0.05 tokens per second, slow but fully correct. The model never loses precision. Placement decides speed, never accuracy. The same int4 weights, the same router decisions, the same output, whether an expert answers from VRAM or from disk. Now let's talk about the engineering. The entire Colibri engine is a single C file, c/glm.c, roughly 2,400 lines of code. No Python runtime, no BLAS library, no CUDA required. It compiles with just GCC or Clang in seconds. Zero external dependencies. That's not a simplification, that's a design philosophy. The engine is deliberately small enough that anyone can read it, understand it, modify it, and contribute to it. And it's not cutting corners. The forward pass is validated token exact against Hugging Face transformers, using teacher forcing on 32 sequences. Bit-for-bit identical output. It implements multi-head latent attention, MLA, which compresses the KV cache to 576 floats per token instead of 32,768. That's a 57x reduction. And GLM's native multi-token prediction head drafts 2.2 to 2.8 tokens per forward pass using speculative decoding. Colibri includes a built-in web dashboard that you launch with Colibri. It gives you real-time visibility into everything the engine is doing. Live token per second metrics updating as the model generates. Time to first token measurements. A per turn time breakdown showing exactly where the compute is spent, attention, expert routing, I/O cache lookups. The memory tier bar shows the real-time distribution across VRAM, RAM, and disk. You can literally watch experts migrate between tiers as the cache warms up. And in the corner, there's a live mini-brain visualization showing routing activity in real time. This isn't just a tool, it's an observatory for watching how a frontier AI model thinks. The brain page is one of the most stunning visualizations I've ever seen in an open-source project. It renders all 19,456 experts as a living cortex, a massive grid where every single expert in the model is visible at once. Color represents the storage tier, green for VRAM, yellow for RAM, red for disk. Brightness represents routing heat. The more often an expert is activated, the brighter it glows. And when an expert fires during inference, it flashes white. You can hover over any expert and see its measured topic affinity, which subjects it specializes in. Poetry, law, Chinese language, SQL queries, mathematics. Every expert has a personality. This isn't a toy visualization. It's a real-time window into how a 744 billion parameter mind organizes its knowledge. The Expert Atlas takes this even further. It plots 13,260 characterized experts as a 3D galaxy that you can drag to spin. Each point is an expert. Position in 3D space represents measured routing affinity. Experts that fire together cluster together. You can see 41 replicated specialists forming visible topic clusters, poetry experts grouping near literature, SQL experts near database code, Chinese language experts forming their own constellation. And here's what makes this special. These positions aren't learned embeddings. They're measured from actual routing behavior, real data from real inference. This is genuine scientific visualization of how a mixture of experts model organizes itself. Let's look at the real numbers. Same engine, same int4 model, only the hardware changes. At the top tier, 6 RTX 5090s with full expert residency. You get 5.8 to 6.8 tokens per second with a time to first token of about 13 seconds. That's a 744 billion parameter model running at conversational speed. On a 128 gigabyte CPU-only desktop with no GPU at all, warm cache gives you about 1.8 tokens per second. That's usable for code generation and long-form writing. A single RTX 5070 laptop class GPU hits 1.07 tokens per second via the GPU resident pipeline. And at the honest floor, a 25 gigabyte dev box streaming everything from disk, 0.05 to 0.1 tokens per second cold. Slow but fully correct. This is where the project started and it's still the proven baseline. The engine never lies about what your hardware can do. Getting started is almost comically simple. Step 1. Clone the repo. Git clone github.com/ just vug/colibri, then cd into the directory. Step 2. Compile. Just run make. It takes seconds because there are 0 dependencies to install. No pip install, no conda environment, no cmake configuration. Just make. Step 3. Run it. /Coli chat starts an interactive conversation. The first time you run it, it downloads the model shards, about 370 gigabytes for the full int4 model. After that, it's all local. You can also run Coli Web for the web dashboard, or Coli Serve for an OpenAI-compatible API endpoint that works with any existing toolchain. For dual SSD setups, point the mirror to a second drive and get up to 33% more read bandwidth. The engine measures both drives at startup and routes experts automatically. That's Colibri, the tiny engine that proves frontier AI doesn't have to be locked inside data centers. A 744 billion parameter model running on hardware you already own. Pure C. 0 dependencies, and the most beautiful model visualization I've seen in any open source project. Link to the GitHub repo is in the description. It has 18,000 stars, and the community is incredibly active. If this blew your mind, subscribe and drop a comment telling me what hardware you'd run it on. See you in the next one.